consultant. I'm trying to be involved in the data community as a speaker and also as an organizer. Also, I'm the co-founder of the SQLDay.net, the blog where you can find a lot of different data-related articles. So I already encourage you to visit later on the blog and find something for yourself. You can also find the social links to myself, so feel free to connect and to be in touch with me after the presentation. I'm always happy to talk about the data related stuff. So yes, I would like to say that I'm passionate about the data in many different ways and possibility. But actually, I would like to start with a small confession with you. So I would need to tell you that for way too long, I was focused too much on the one single technology and one single vendor. To be honest, I was programming a bit since I have joined the IT, but anyhow, it was only the one vendor and one technology. It was the SQL Server, like multiple services from the SQL Server, but only one technology and one vendor. I was always trying to look for something different, but I always found a lot of different new tools and technologies to be too complex. I attended the sessions, but then I thought that this is too complex and I won't even try. So then I thought to myself that's the time for a change. And then I was trying to try something new and gain some more knowledge about the new technologies. So if you also recognize yourself in any of those 2 points, then probably that's the session for you, and I will try to show you how to learn new things and also some examples of the new technologies that we can learn. If that's not you, then yes, still I believe that you should gain some knowledge from that presentation. So how to proceed and how to learn the new stuff. We could talk about that for 1 hour, but I will focus on 4 main parts here. So the first one is to try to find the good learning materials. I will try to share you some of the good learning materials after that presentation, but also you can always ask the other persons. Ask on the Facebook data community page or at the conference what are the good materials to learn something new. Also, you can find that online. Always, also, don't think that everything is complex. I believe that if we won't focus too much on the details, we'll find that actually everything is quite simple, and if every tool and every technology, we can really proceed and create something useful even on our own environment. And yes, one of the best advice I could give you, and in my opinion, one of the best idea to learn the new stuff is to create the pet project. The pet project will be the project that you can create on your own, in your local laptop or in your private life, that will allow you to challenge to create a project with the technology that you really like. And I believe that's the best way to learn anything, because then you will find the challenges that you won't find learning from the online classes or trying some very simple task. So I encourage you to pick up something like the topic and some tools and try to create the projects only on your own. And today the idea of that session is that I will show you my pet project that I have created in the last few months, and that also allow me to learn some new things. And as we'll go through the project and the demo, we'll also try to get some knowledge about the technologies that I have used for my projects. So my pet project is the radio playlist analysis. So let's say that you have the list of all of the songs that were played in the radio for the last years, and you would like to create the data product out of it using some new technologies and to learn some new cloud services. So the main goal for me for the projects was to learn some cloud services, a bit of the big data, a bit of the data engineering in the cloud. And also at the very end, my final goal of the project was to create a machine learning model to predict if my favorite song will be played in a given month or not. So we will see all of those, the entire project from the very start to the very end, in the next 50 minutes or so. That's the tech stack that I have came up for my projects. Of course, you might think about different products and different tools to create such projects. That's my proposal that I will show you today. Maybe later on you will get my code and you will extend with some different tools, or you will use the different tools to create the same project. So, of course, I don't have such data on my laptop. I don't work in a place where I can find those data, but luckily there are some websites that can provide such information. So the first demo and the first thing that I need to do was the Python script to get the data from the web. Then I was running the script in the Docker container. The Docker part we will skip here, but I encourage you to check Docker because that's the really nice way to learn the new stuff and run many different tools on your local desktop without messing up with your local environment. Then if we will have the data, then of course we could save the data to the database, but that would be too easy, right? We are creating the modern data solution, so we should save the data to the data lake. So that's what we will do. And then once the data will be on the data lake, we should manipulate and process the data. And in order to do that, we'll use the Databricks. That's one of the most commonly used product for the data processing we have. And then to check some data, we will and get some insight, we'll use the Power BI. And finally, after all of the data is prepared, we will use the Python and Azure Machine Learning to create our model that I told you before. So I ask you to fasten your seatbelt because I believe it might be a bit fast. I have really a lot of things to show you. Of course, we won't go into the very details. We'll simplify a lot of things. I will also show you only the parts of the demos, but at the end I will share with you with every demo and every code that I have plus more. So later on you will be able to follow up and check every demo and every line of the code. The idea here is to give you the rough idea how it looks like to use different technologies, and to show you that actually this is not that hard. So saying that, we are after the intro phase, and right now it's time for the first demo and some theory. So the first thing that I need to use, as I said before, is to get the data from the web. And in order to do that, I would need to use some Python like programming language to get those data. And I will also stay with that for a minute, because I believe if we are the data engineer nowadays, then most probably we should aim to learn at least one programming language for sure. Of course, this is not mandatory. Of course, it depends what you are going to do. But in many cases, if you are going to be a data engineer in the cloud or to be a data science engineer, then most probably will end up anyhow writing some code in any of those languages. So in my opinion, one of the best choice would be Python, because we have many great libraries to work with the data, and this is very popular. But of course you can choose Scala or R for the data engineering. Probably all of them will be just fine. So we will see some Python script as well, and actually the Python will be with us for almost the entire presentation. So we will also see that actually with the data engineering, especially in the cloud, actually the programming is really needed, and we should know at least the basic of some programming language. Before we will jump into the Python script, I believe it's a good idea to clarify the data lake already, because we will save the data there. So the data lake is very common buzzword, and I believe that sometimes it's too complicated than it is in the reality. So at the end, the data lake will be just like the file share, just like the special disk that you would use to store all of your data. Of course, this will be in the cloud. So this is like the file share in the cloud. And the data lake will be the central repository of all of your data that you will store there. You will store those data in the files. It doesn't really matter if the files will be structured or unstructured. You can put them at least in some layers as JSON files, as text files, CSVs, and so on and so on. So you will create the file share with all of your data from different sources on the cloud. Now, to make sure that there will be not a lot of mess on the data lake, we of course need to maintain and create some sort of the rules for the data lake. And that's what they call layers in the data lake. But at the end, the layer is just the one directory that is created for the specific purpose and that describes the state of the data. But at the end, this is just a directory in our file share. So if we would continue talking about the layers, that's one of the common approaches you can see on the right-hand side. So the layers like raw, curated, enriched, analytics, and so on. And just to give you a rough idea, the raw layer will be the first layer where you will put all of your data coming from the source. For example, it might be the data from SAP that is written in the CSV files. And then you will proceed with your data processing, with your data engineering project, and moving the data around to the different layers. So the next layer could be the curated layer, where you will use some tools. In our case, we'll use the Databricks to get the data from the raw layer, like combine, handle the delta, maybe maintain the data types, and save into the different layer in a better shape for later purposes. This will be the curated layer. And now in the curated layer already, we most probably will use the Parquet files. So most probably in the raw layer, we will have the JSON file, the TXT files, but here we'll use the Parquet file. And this is most probably what you will heard if you will heard about the data lake. So what is the Parquet file? That's another file format that we can find. You can create the Parquet files with any programming language. And the key part here is that the Parquet file will compress the data in the columnar format. You can think about the Parquet like about the column store index inside the SQL server. This will be a bit similar. And storing the data in the Parquet file, we can actually have multiple smaller parts of the Parquet or of the single Parquet file, which makes this really, really beneficial for the data processing in the cloud, especially if we have many different servers to process our data, because then we can split the different parts across the multiple servers. And also the data are compressed, so that's one of the common file format that we could use in the cloud. So basically, that's all you need to know regarding the data lake at the very beginning. Maybe there will be also something about the partitioning, but this will be just about the splitting the data in many different directories in your file share. So we need to make sure that the file is not too small and not too big, like it should be around hundreds of megabytes to make the processing fast, and also the partitioning, so splitting the data into the multiple directories, will help us with the security. And that's all. That's the data lake. The data lake, we can create the data lake in Azure using the storage account. So that's the resource type that you would create to create your data lake. I will later on, after the presentation, share you the code how to create the storage account and how to create the data lake on your own. So if we will create the storage account in Azure, then we can create some directories, and this will be our file share, our data lake. Also, we can use the Microsoft Azure Storage Explorer, which is exactly doing more or less the same thing, but this is the desktop application. So you can also connect to the data storage, you can maintain and browse your data lake. So let's see the first demo. The first demo will focus on getting the data from the web. So as I said, we don't have such data, so we'll use the web page that is providing such information. So there is a page called odsłuchane.eu, where we can find the radio station. We can put the particular date and the particular hour, and if we will click on the search button, we'll get the list of all of the songs that were actually played in the particular day, in the particular time, in the particular radio station. And as you might see is if I will change my filtering criteria, the URL will change. So actually the entire idea will be to create a Python script that will create the proper path of our website and then parse the content of the page, and at the end save the files to the data lake. Now, of course, we won't go into every and each line of the code, but the key part with the programming is, if you have never programmed, is that, of course, we won't create everything like this from the scratch. Like, we won't parse the HTML code on our own and to get those information. Luckily, we have many different libraries that we can just import and we can use to do our stuff. And therefore, we have the libraries for the web scraping, like Beautiful Soup, and the request to get actually the HTML code, so later on we can easily parse that information. And also we have some libraries to connect to the Azure Data Lake and to write the data to the data lake. So our code will looks like that. We'll of course get some parameters like what kind of date range we would like to have and the radio station name, and then we will iterate basically through each date in our date range and through each hours, and we will create the proper path. So we will have the radio station ID in that case, we will have the date time, the current date, and we will have the hour from and the hour to. And later on we will have some code to get the data from the web page. So first of all, we will use the request library to get the HTML content. Then we will use the Beautiful Soup to convert that content to the Beautiful Soup object, so we can easily retrieve the information from the HTML code. And later on, as you can see here, we can retrieve the particular object from our web page. So here I will find the tbody. That's the name of the table in the HTML code. If we would take a look into the HTML code, we would find that. And later on, once we have the table, maybe you are familiar with HTML code. All of the rows in the HTML will be marked as tr, so we'll find all of the rows. And later on, for each row, we will find all of the columns. So that will allow us to get the song artist, and the song name, as well as the timestamp. Then at the end, we will just put those data to the list of the songs that we will be at the end saving. And with the saving, we will save as the JSON file. So we need to convert the temporary list to the JSON object. And then we need to save to the data lake. So we specify the directory path. Again, this is like a file share, so we specify the directory. We specify the file name, and then we have the connection to the data lake. So the entire connection to the data lake here is just 5 lines, and we can basically save our data in 2 lines of code to the data lake. The rest is the connection to the data lake, and once we have the connection string that we can find on Azure portal, it's super easy to write those data. Now, if I would run that file in my terminal, you should see that this is actually working. So after a couple of seconds, we will see that the data is coming. So of course, this is the sample, so we will get the data from 3 different days for the one particular radio station. And now, if I would use my Azure Storage Explorer application, then I can access my file share, my data lake in Azure. So we have those layers. Maybe I have a bit of the mess, but that's when I was also learning, so please forgive me. But among the different layers, different directories, we will find the raw demo layer. So again, this is like directory. We will have our RMF-FM. This is the name of the radio station, and that's our file. As you can see, the file has been modified like a couple of seconds ago. So that's where exactly we have saved our data. Of course, for my pet projects, I need to run the script for to get all of those data. And so here in the layer called row initial, in that particular directory, we'll have the data for 10 years for 4 different radio stations. So we have, for example, SK, and here we will see all of the song list from the entire year for that particular radio station. And that's the data that we will use later on. All right, so that's the first demo. That's the Python, that probably the programming that we should learn, and the data lake that will be most probably commonly used if you are the big data engineer, but also if you have, for example, the data warehouse and you are migrating to the cloud. Most probably we will end up in the data lake anyhow. So where we are, we have the Python, the Docker part we skipped, but you will get the script and some instruction how to put the script into the container and perhaps run in the cloud as well, but that's out of the scope for now. And finally, we have the data in our data lake. So currently we should process the data, and for that we can use the Databricks. And now we can think about like why we need the Databricks. Like we could create for example, the Python script to process the data, or for example, use the Azure Data Factory or the other tools. And now let's imagine that you have a really large amount of the data, like petabytes of data with many different files. And if you would need to process those data, of course, this would take a lot of time, even if you have a large server. What you could do actually, you could buy some larger servers and try to run, but of course there will be a limit anyhow, right? So the other option would be to create like multiple different servers and split the work across multiple servers to process the data faster. But of course that won't be that easy, because then we would need to program this somehow to split the work across multiple servers and to make it efficient and also not messed up with the data. And that's basically how the Apache Spark has been created. So Apache Spark will be the engine to process like large amount of the data in a very efficient way across the cluster. And that's the Apache Spark. But apparently, this is not that easy to create the Apache Spark cluster. Like the maintenance and also the creation of the cluster is not that easy. So actually, that's why the Databricks has arrived. And to be honest, or to be precise, this is actually the same team that has created the Apache Spark that has created the Databricks. And the Databricks is like the additional tool that is helping us to work with the Apache Spark engine in the more efficient way. So we have the tool that is allowing us to create the cluster, to set up the entire environment in a very easy way and run that on the cloud. So the Databricks will be additional tool that will stay on the top of the Apache Spark. And we will get the same functionalities and the same great performance from the Spark, as well as all of the supports from many different languages that Apache Spark is providing, like Python, Scala, R, and many, many more. And in Databricks, we'll create our pipelines, our code in the so-called notebooks. The notebooks very similar that you can find in the Jupyter Notebook or in the Azure Data Studio that we currently have. We'll see the notebook in a second, but of course, we won't be able to see all of the notebooks that I have prepared. So just to be on the same page and just to give you an idea, I will right now share with the notebooks that I have created in order to process our data and also to follow up with working with the data lake. So the first notebook that I have created is the notebook that gets the data from the raw layer. We have the JSON file there, and then process the data, like handle the data types, and save as a Parquet file in the curated layer. We'll also change the partitioning here. So we'll read the files and we'll make sure to put the files and split them into the directories that we want. We will see the demo in a minute. Then the next notebook that I have created is the notebook to get the data from the curated layer and put the data to the enriched layer. What we will do here, we will actually, out of the entire playlist, we'll create two files. The first one will be just a copy of the playlist data with some data cleaning performed, but this will be exactly the same data set, and we will put to the enriched layer. But then what we will also do, we'll get the list of the unique songs from the entire playlist from all of those years, and we'll try to enrich those data with the Spotify API data. So there's the Spotify API that is actually free, and you can get the additional information about every song, like the album, the release year, but also, for example, how danceability the particular song is. So that will be the second notebook. Of course, the songs will also save to the enriched layer. Then the third notebook will be used to create the tables inside the Databricks. And now you will also probably heard about the tables if you are thinking about the Databricks. And the entire story about the tables in the Databrick is that the table will be just the additional view. It's not actually the table, it's the view that is allowing us to connect the Databricks cluster, create the view on the top of our data lake, and make later on the data available from the data lake outside the world using the Databricks cluster. So we just create the view resists on the top of the data, and then using the Databricks connection string, actually I believe this is the JDBC, we can really connect our data lake using the Databricks cluster. And with the view, we have the proper columns, the data types, that's like a table format here. So that is the third notebook. And the last one is to create and prepare the data for the machine learning. And that is maybe a bit more complex, but just to, like the code is very simple, but the manipulation is more complex perhaps. So from the raw data, we have the radio name, we have the timestamp, we have the artist and the title. And actually what we will do here, we will try to get all of the unique songs, then we will get all of the unique years and months and all of the radio stations, and we will cross-join everything. So we'll get all of the possible values from all of those tables. And at the end, we will merge the data and group by the month and the title. So at the end, we will get the information if the particular song, like all of the songs, all of the possibilities, if the particular song has been played in the particular month or not. And then if we will join back to the original data, we can of course mark some of the songs that were actually played. So from here, we will go to the data set as we have on the below table. So we will have the radio name, the month name, the song, and the information if the song was played or not. So that's all of the Databricks notebooks that I have created, and let's see at least a sneak peek of the Databricks now. So the Databricks is running on the cloud. You can run the Databricks on AWS and on Azure. And the good thing is that we have the community version of the Databricks that is like providing all of the possibilities that we have in a full version apart from the jobs. So you cannot orchestrate the notebooks, and the other limitation will be that the cluster will be limited to the single node, but apart from that, you have the full scope of the Databricks for free. So that's a great news. So here we have 4 notebooks. Of course, I will share with them. But just to give you an idea how we can work with the Databricks and the data lake, I will open one of them. So first of all, that's the notebook. So we have the markdown here that we can describe our code, and we'll have also the cells to actually write our code. Now, the first thing, if we would like to work with the data lake, is probably the connection. This is not the best choice to put the secret inside the notebook, but of course there is a Databricks secrets that we can use. This is just to make the presentation easier. But this is also written here that this is not the best way, and how to make this better. So first of all, we need to set up the connection to the data lake, and then we can start working with the data lake. So first of all, we can run some data and see what we have on the data lake. So here we will actually see what kind of files we have in that particular directory. So that's the row layer, and that's the one particular radio station. So that's what you have seen also in the previous demo. This is the list of the files we have here. Now, if we would need to do some manipulation, first of all, we will actually need to read those data. So with the Databricks, with just a couple of lines, we can specify the structure of our data. So we can even extract the partial information from the single file specifying the schema, and later on we can read the files. Now, in most of the cloud services, we'll be able to read multiple files at the same time. So here we know that all of the files has the same format, so we can actually read all of the data from all years and from all radio stations using the wildcards in the path. So it will get all of the files and read later on all of those files. At the end, here you can see that we rely on Spark. We can perform the read operation, we can specify some additional parameters for the connection, and we can read the JSON files from the path. Now, if we'll execute the command, this will actually create the data frame, and the data frame will be the object that later on we can create the manipulation of our data. Of course, we can also get the metadata of the data frame itself, like the schema. Later on, we can work and perform some operations on the data frame, as I said. So, for example, we can perform the count, and here is the number of rows, all of the songs that were actually played on the radio songs. So maybe that's not a big data, but still we have almost 5 million of rows in our data lake. There is some magic comments to, for example, display the data in the worksheet on the notebook itself. But the most important part here is the data manipulation, so the processing of the data. So what we can do here is actually the same what we can perform in every other SQL engine or any other data engineering tool. So we can perform the select. We can also add the column. We will add the column with the with column function. And then we can specify that we would like to add the year, and we will extract the year from the date time that we have on our data frame, right? Of course, we can add multiple different columns, and at the end we can specify once more again what kind of columns we would like to have as the output of the data frame. So after those operations, if we would look into the data, we'll see that we have currently the radio name and the year derived. The radio name is derived from the path actually, and the year is derived from the date time. Of course, there is multiple ways. We can even perform the group by or the aggregate functions. So actually what will happen here, we will group by the radio name and we'll count the number of transactions. So later on, we'll be able to see what is the split of the data per radio station. And now in the Databricks, you can visualize the data using the table, but also there is a built-in report functionality, so you can create some simple charts in automatic way. You don't really need to use Python or additional libraries to create the simple charts. So we know how to manipulate with the data. Probably you have the look and feel. So at the end, after our manipulation is done, most probably we would like to save the data back to the next layer of the data lake. And again, with the Databricks, it's super easy. We just need to specify the directory. We specify the mode, this override. So we'll always overwrite the files that will change. And we can also specify the partitioning. So with that, Databricks will make the split to the directories for us. So we will see that in a second. But this will be made automatically. And at the end, I told you already about the Parquet. To make the later operations more easy, we will convert the data to Parquet. We can read the files using the read operation and providing the path. And then we can perform the manipulation. So we can do the select. We will add new columns to our data frame with the with column function. And later on, for example, we can perform the group by, the aggregate functions, and many more. And also, this is the built-in functionality to create the charts. And once all of the operations is done, we can export the data to the curated layer, the next layer, so we can perform the write operation with the partitioning and change the data type, the type of the file to the Parquet. So right now, if I will go to the data lake, and if I will go to the curated layer, you will see that currently we have partitioned the data and we have the radio name here on the directory name. If I will open one of those, we have then partitioned by the year. And if I will open the particular folder, we will see actually the Parquet files. As I said, there might be one or multiple files from Parquet with some metadata. So this is just how the Parquet is working. So that's the first notebook. Of course, those are the 4 notebooks that I have created. I will share with all of them. And they look almost the same. We have just a bit different manipulations. So if you will look into the next notebook, as an example, you will still select. You will still see like a select with adding some new columns. Maybe there will be some additional functions like where. That's also possible. We can also perform the distings and so on and so on. So everything should work just fine. That was the demo and the next phase of the projects that I have created. So once we have all of the data in the different layers and prepared for the later usage, we can continue our project. So the next phase will be the Power BI. I won't go into the details here. You probably have heard about the Power BI already, but just to be on the same page, Power BI is the reporting solution and analytics solution, visualization solution made by Microsoft. There is a free desktop version that we can use completely free, and there is a non-free cloud version where we can share our reports. So let's see what kind of the reports we could create using our data. Let's hope that you will see my screen. You should see the Power BI report right now.
Yes.
Okay, great. So later on in the presentation materials, you will find how to connect to the Databricks from the Power BI. This is as simple as providing the connection string, but you will find how to do it. And once you will do, you can of course create the different visualizations. So this is the 3 different reports that I have created to show you. So the first one is the number of songs. So this is almost 5 million of rows that we have on the data lake, like 4.6 millions. And we have like 40K of different songs that we have found on all of those over the years and over the radio stations. And the first insight we might get is that, for example, the SK radio station is playing much more songs comparing to the other radio station. So most probably the other radio stations is providing more like discussions during the radio time. The next insight we might have is the analysis of the most popular songs. So currently we have the split for different radio stations in the different tabulars and for the particular year. So for example, here we have the top song from SK. The top song, which is Sana, the very popular song in Poland, was played like 90 900 times in 2020. I'm not sure when the song was released in the particular date, but this is really impressive. And of course, you might find that the same songs can be found on many different radio stations, apart from maybe the anti-radio. So the name is probably valid, because most popular songs that you will find on the other radio stations, you won't find on the anti-radio. And the third example is the audio feature analysis. So that's the data from the Spotify API. So as an example, the first bar chart will show us the densability. This is how densability the particular song is, and we have the average, the weight average for each radio over the years, and we can find that the SK radio station is playing more densability songs than any other radio station we have in that analysis, especially comparing to the anti-radio. And like knowing the Polish radio station, that would make actually sense. That seems to be valid. So Power BI is free in the desktop version and is really great for the ad hoc analysis and for creating such report and insight from the data. So we are done with the Power BI, and now let's move on to the last demo and the last subject that I have worked in the last months or years, and that I would like to show you today. So the machine learning might be very complex, and I won't go into the definition that we might find on the web. The key part here with the machine learning is that we work with the data, and in most cases we will try to get some predictions out of the data. And now we will have multiple ways how to do it, but the key part here is that we will find some common patterns and some common tasks that we will try to solve with the machine learning. So in the first example, the point number 1 and the table number 1, we have the year, we have the customer, we have the product category, and we have the sales. We have the sales from 3 different years, and what we will try to do, we will try to predict the value, the sale for 2021. So that kind of the task will be called the regression. And by the way, we have the sales amount from the previous years. So this will be the supervised machine learning, because we know the labels, that's what they call it in the machine learning word, from the previous data. Then the other task, the other table is that we have the data from about the customer, the last 3 months sale, the last 6 months of the sales, and the number of transactions. And now we can ask the data analyst to analyze the data and put the labels to the table. Now this example is trivial, but the data analyst could say that the frequent buyer is the person that is making a lot of different transactions and has a very large amount of money spent on our shop. And if we create such labels, then we can predict the label, the category of a new client, of a new customer. And that kind of the task that we'll try to solve is the classification. That's also what we'll see in the real demo later on. And again, we have the data from the past, so this is the supervised machine learning. And the last example, the table number 3, is the case where we have the similar data, the sales from the last 3 months, the sales from last 6 months, and the number of transactions. And probably we should have some more features, but we don't have any existing category. So if we don't have the data from in the existing data set from the past that we'll use to create and train our machine learning model, this is called the unsupervised. And that kind of the task will be called the clustering. So the machine learning will automatically try to group all of the data and create some clusters, some groups that is grouping the customer, so the similar customers are on the same bucket. So, of course, in order to perform all of those tasks, we won't do it manually. And there are plenty of different libraries for Python or any other programming language that we can use to actually solve our task. And for different tasks, we'll have different algorithms. So the algorithm will try to solve our task. And the main problem with the machine learning at that stage, at least, will be to of course, prepare the data a bit, but then find the algorithm that will fit our task, like regression, clustering, and classification, and also to fit our data. But luckily, we have a different cheat sheets that we can find on the web. So at the very beginning, we can really find some advices which algorithm we should use in which case. Yeah, that's one of the cheat sheets that we can find. And later on, if we have the data, we have the problem, we have the algorithm. If we'll apply the particular algorithm into our data set to solve the particular task, then we'll create the model. Like we will, with the data set and using the algorithm, we will train the model. So later on, we could reuse and predict the next data. So that's the theory. From the practical point of view, it will look like that. We have the data, that's the year, customer, the category, and the sales. So we get the data. Then most probably we'll perform some exploratory analysis, that's what they call it. So we'll get the insight about the data, like the average of the columns, like the unique values, if anything is missing, if the data is skewed or not, what is the distribution, that kind of stuff. So we should understand our data. Then in most of the cases, we will need to perform some preparation for our machine learning models. So as an example, for the scikit-learn library, in many different algorithms, we shouldn't use the text fields like the product category. We should encode those values to the numeric values. And there is many of different ways how to do that. But the good thing is that we have some libraries and some functions. So we want to do it manually. This will be just one or couple of lines of code, and this will be done for us. Once that is done, we will specify the features and labels. So the features will be the attribute list that we'll use for learning our model, and later on that we will use to get the prediction for the new customer in that case. The label will be the predicted value. This will be the column that will be used for the prediction. Once that is done, then we will usually also split the data into the two different subsets, the train subset and the test subset. So with the train subset, we will learn the model. So we'll ask the algorithm to create the model to be able to predict the new customers. And then we will use so we will select the algorithm and train the model. And then later on, we will use the test subject to actually verify and validate the model. So what will actually happen is that we will get the part of the data that we know the label already, and then we will, after the training model, we will use the features to find a new predicted value, and we'll compare with the actual value. So that's what we can see here. The actual sales from 2019 is 210, and from the model we have got 210, so that's fine. But for the 2021 we have 220, but we have got 240, so that means that the model for that particular case didn't work properly. Of course, if we have a very large number of data, we won't check that manually, so there will be also some metrics that will tell us how accurate our model is, or for example, how many errors have we made on the way. So that's like a flow from the Python perspective or programming perspective. Actually, to create the model will be as simple as creating those three different pieces of codes. So first of all, we'll split the data set into the features and labels. We know what it is. We split later on the data set into the train and test subsets. We also covered that one. And later on, we will select the algorithm. In that case, this will be the logistic regression algorithm. And we will use that for learning the model, and at the end we will have the validation. So here one of the metrics will be the accuracy, which will show like how many cases we have predicted correctly. And also below we will find the confusion matrix. So this is also showing how many times we have predicted correctly, like if we were the categories and so on. Of course, we won't go into details here, but you will find the example on the notebook that I will share you after the presentation. So that's the machine learning. But also I have said that we will use the Azure machine learning. And now we might have the question, why do we need the Azure machine learning? Because actually what we could do, we could use, for example, the Databricks or even the local desktop to create the machine learning model, and that would work. But then the next phase of the machine learning product is to actually publish and deploy our models. And that's where the Azure Machine Learning can help us. So with Azure Machine Learning, we can not only build the models and validate them in a very nice way and organized way, but also we can deploy the models as the web service. And hopefully we'll see also the demo in a minute or so. By the way, Azure Machine Learning supports Python and R. So again, there is Python, but if you would like to switch to R, that's also possible. Yeah, let's see the demo and let's hope that this will work this time. So Azure Machine Learning, it's one of the resource type that we can create on Azure portal. That's my resource group, and that's my machine learning workspace, so I can launch the studio. That's the place where we can actually work on our machine learning models. Okay, most probably we will extend the presentation like 5, maximum 10 minutes. Hopefully that's fine for you, but we had also some problems. So I will show you 2 notebooks. The first one will be like a code that you could easily create on your local environment to create the prediction model. And the last one will briefly see how easy it is to create the web service and really publish our machine learning model to the world. So of course, first of all, we would need to connect to the data. That's a common path. I will skip that one. I will share with the code. Basically, we need to provide the information to our data storage. So yes, with the machine learning, Azure Machine Learning, first of all, we would need to connect to the data set. I will share with the code. Please remember to not store the credential here in the notebook. There is a better way. There you will also find the material how to do it. And yeah, after that, what we can do, we can browse our data. This is the same look and feel actually what we have on the Jupyter notebook or the Databricks, the same look and feel of the notebook. So this is our data set. Then of course we can analyze the data. This is a very good information, but of course I will skip that part, unfortunately. Then what we can do, we can create the numeric values out of the categorical, like text fields. Again, from the very simple models, the label encoder maybe would work, but that's not the best choice. You will see the better way in the next notebook, but that's just to show you the idea. So here, for example, we have encoded our data to the numeric values. Then we have the same code from the presentation. So we split to the features and labels. We split to the train and test subset. And then we have our model. In that case, this is the logistic regression and the validation. And here, unfortunately, I won't go into the details, but here you can see that the accuracy is really large, but actually the number of values that we predicted correctly is not that high. So the key information here is that most probably you would need to check many different algorithms in order to find a best way. Later on, of course, we can reuse our model. That way we can reuse the model from the file as an example. And that's the core of my presentation and the entire idea for my project. I was trying to predict if, for example, the last Christmas song will be played in the given month. Of course, that's a very trivial case for the machine learning, but I believe this is showing that it really works. So what we will do, we will check if the last Christmas song will be played for the particular radio station in 2 months, in December or in June. We have 2 different algorithms. The first one is, as I said, wrong. The second one should be better. And actually here we can see that our model has predicted that the last Christmas song will be actually played in December, but won't be played in June. So that would make sense, right? And we can also do the same with the other song. That's the the famous Polish summer song. So again, if we would repeat the exercise, we will get the prediction from the model. And here we can see that the model predicted that in December, that particular song will not play, but in June it will definitely be played, or most likely it will be played. So yeah, we are running out of time. With Azure Machine Learning, you will find the demo in the notebook number 3. With a little more effort, we can actually make the code productive and deploy as the web service. So just to give you an idea, this will be our code. Actually, if we would remove the logging from here, it would be very, very similar to the previous state. Like we split the labels, the features, the train, and the test. Here we are using a bit different encoding things, but at the end, this is the same code. We only will add the Azure machine learning stuff like logging, creating the experiment, and registering the model. So if that will run, we can create out of it the web service, and at the very end, we can use really the API address. So that's the URL, and we can use that to do the same prediction. So again, the December and the last Christmas, June last Christmas, and we should get exactly the same values. And the very good thing is that if I will go to the machine learning portal, I will find all of the information about my model and all of the runs that I have performed in the Azure Machine Learning Studio. So that's my model. I call it Try Something New, songs. I can find multiple runs that when I was working on that model, and also we will be able to open the particular execution, the particular version of the model, and we can see who has executed and when, as well as, for example, the logs. So here, for example, we will find our metrics from our machine learning model training. And for example, here we can even see the confusion metrics. So yeah, unfortunately, we lost some time on the way, but of course I will share with everything, and you will be able to follow up later on. So that was the demo about the machine learning and the Azure, and therefore we have covered all of the demos and all of the theory that I was trying to share with you. I believe we have seen a lot, but my goal was to show you that actually every technology and every piece that we have seen is not that hard. So the data lake, the Databricks, and even the machine learning at the very beginning, or at least to start, it's not that hard. There is also a lot of repetition on our code that we can really copy from one place to another place. So we won't invent this in every machine learning or data project, so that we will only handle the particular task, and the rest we will just reuse. We have seen a lot of different tools. Probably we could use the others. If you like the analysis of the songs and perhaps don't like the Python at all, there is a blog post on blog.prokulski.science where you can find an analysis of the songs from the radio using R. This is without the machine learning and the Databricks. This is pure R and on-premise, but still I believe if you like the topic, you will find a lot of useful information there. And that was also a bit of the inspiration for me for that presentation. Of course, we could extend our project with different additional tools, or perhaps you could use a different tool set. That's completely fine, and maybe you will try that for yourself. I hope that you have seen something useful and that the session was informative for you. There was many different simplifications, but the point was to show you that this is actually much easier than we might think about, like machine learning, the data lake, and the Databricks as an example. And I encourage you to perhaps create your own pet projects, think about something that is really interesting for you, pick up some technologies you would like to learn and use, and create the pet projects on your own. If not, then at least try to use a bit different technologies, or at least try to learn programming, because I believe this is a lot of fun and will give you also a lot of technical knowledge. Always please try to slice the elephant and don't focus too much on the details, because really the stuff is easier than we probably think. Please remember that today we have seen a lot of cloud services and tools. So please remember that you might get the free Azure credits in many different ways. Please remember about that. And then why not to learn something new, or at least try. I encourage you to do so. That was a pleasure for me to talk to you, and thanks for coming to my presentation. I hope you had a great time. I also wish you a very great the rest of the conference. Sorry about the issues we had on the way. If you will have any question, please reach me. I will be here nearby on the Avatar Land, or please send me a message on Outlook or Twitter or whatever. It was a great pleasure, and thank you.